Let's get started. Welcome to the Anyscale Governance Suite, tools to support AI at scale. In this session, we're going to go through some of the frameworks, tools, and features we built on the Anyscale platform to help support AI platforms, build guardrails, and make sure that people can get the best use out of their compute resources. My name is Dominic Catalano. I'm one of the product managers at Anyscale. I'm joined here by Alan Yin, software engineer for Anyscale. The latest wave of AI, particularly generative AI and LLM applications, has put AI at the center of most business strategies. This is a new technology that people can actually see, touch, and interact with. So people are starting to rethink how they actually consume infrastructure and invest in different AI projects. If you're an AI platform leader, you're tasked with the challenge of supporting new projects without risking security. You need to encourage developers to experiment and deploy with common guardrails. Ultimately, you need to make sure that your platform and your applications can scale with the workloads that you're trying to put into production. So over the course of this session, we're going to cover 4 key areas. We're going to first start by talking about security and permissions, how we think about things at Anyscale, and provide some general best practices. We'll talk about cost management and governance, and some of the tools and features we built to help make sure that you don't incur the cost of AI sprawl. We'll talk about observability and integration, some of the things that we built in the platform, as well as how you can extend that to support your own needs. And then finally, we'll talk about automation and some of the things we do there to make sure your production story is as easy as possible. Let's start off with security and permissions. Security is something that is so incredibly important to do right, but also extremely difficult. I think we've all been in a situation where we were hammering away at a problem, finding a permission error, insufficient access, yada, yada, yada. And how many people in this room, seriously, solved it by giving that person or role admin access? Come on, it's more than you. Come on, be honest, be honest. And then how many of you actually remember to scope down these permissions? Sometimes. Exactly. Very difficult to get right. So the way we think about security and access is really no different than the traditional models. These are just extensions of how to take the old models and best practices and move them into a modern AI platform. So high-level guidelines, no surprise here, secure by default. Make it very difficult to mess up. But some of the things that are more specific to an AI platform. Building your platform to be able to isolate workloads into the environments in which they need to run and nowhere else. Least privilege, making sure that the people at your company only have access to the data that they need access to, and nothing more. And that's something that's important if you're managing a platform, being able to increase transparency, understanding what's happening when, by who, at any given time. Opposing this is the idea that as an AI platform, your entire purpose is to facilitate the development of AI workloads. So avoiding developer friction and getting out of their way and letting them drive is incredibly important. So let's talk a little bit about how we think about things at Anyscale. Everything we do starts with a model of how we believe what we do fits in how other people do things. So we break it down into 4 different layers. At the top level is the organization. This is the highest level of isolation we have between our customer tenants. Anyscale manages thousands of organizations, all operating independent Ray clusters every single day. So we need to make sure that inside of our platform, things are isolated strongly at the organization level. Within an organization, where most customers typically spend their time thinking, are clouds. You can think about clouds as a deployment of Anyscale into an environment. We'll get into much more detail here. But this is the strongest isolation within a tenant. Within a cloud, you have projects. These are logical groupings of resources. Projects to us, they're kind of just like folders. They're meant to organize resources, make your day-to-day life a little bit easier by remembering where you actually put stuff. And then within that, you have resources. These are your actual Ray workloads. Your workspaces, jobs, and services, running your Ray applications on a day-to-day basis. An important thing to note here, because an Anyscale cloud is a deployment of Anyscale, typically the clusters that exist inside of it share the same network, they share the same permissions, so it's important to understand where the actual isolation boundary is. We also have different levels of permissions as well. The highest level, you have your organization owner. This is your admin. They do things like grant permissions to various clouds. They deploy new clouds. They delete clouds. They configure billing. Everything you'd expect an admin to do. But the vast majority of Anyscale users, the vast majority of Anyscale users are collaborators. These are your everyday developers, engineers, etc. They're able to create resources. They're assigned to different clouds. You can have one or more. Doesn't really matter. But they're able to run Ray workloads inside of your clouds. Let's dive deeper into what a cloud actually looks like. The diagrams on public docs, don't feel obligated to memorize it. But a couple of things to point out. An Anyscale cloud is deployed inside of a particular AWS account or GCP project inside of a particular region with a particular set of cloud resources. Things that you need, a network, can't exactly just launch clusters in the middle of thin air, as well as some permissions to access different things. A couple of things to call out that are important to the Anyscale design. Anyscale configures Ray clusters via the VM APIs. So in AWS, we'll use a cross-account role to directly hit EC2, and in GCP, we'll use Workload Identity Federation to hit GCE. This is an important consideration because it means that we do not require network ingress into your environment. Your network is entirely configured by you. So if you want your users going over the public internet, over public IPs, by all means, go ahead. If you want your network to traverse a private VPN, transit gateway architecture, direct connect architecture, we can fully support that as well. The only thing we need is egress back out to us so we can make sure that your clusters are operating in a healthy state. Let's also talk about securing Ray itself, especially over the last couple months. Important topic. On Anyscale, these clusters are secure by default. We leverage application level security to make sure that the authentication and authorization matches the Anyscale permission model. So even within your Anyscale organization, you're only granted access to the Ray clusters that you have permission to access. Now, this flexibility of being able to deploy many, many Anyscale clouds and dynamically grant users access to different clouds has led to some very interesting configurations of how people have actually deployed Anyscale. It's a very flexible model, after all. So the biggest one and our biggest recommendation is workload isolation. Deploy your Anyscale clouds where your workloads actually should run. This means that you can deploy compute exactly where your data is across all of your different environments, whether it's staging, dev, test, prod, across different workloads. We also have some customers that are very stringent about who has access and what level of sharing can be done. So we actually have some customers that deploy an Anyscale cloud for every single one of their users. And that's their play space, that's where they live, and that's perfectly fine by us. But there are also other more creative ways people can deploy clouds, whether it's granting access to different accelerators in different clouds, whether you're attaching machine pools to certain clouds to access things on-prem, a number of different ways to configure that. And then calling back, ultimately it comes down to preference. If you want to be in AWS one day and GCP NX, if you want to leverage Kubernetes one day on AKS or Oracle, fine by us. The way you deploy Anyscale is going to be very dependent on how you need to consume infrastructure. Ultimately, putting compute in the hands of your developers. So, some general guidance. Make sure that the way that you think about a platform or the way you might consume Anyscale maps to how you already think about infrastructure. Deploy your compute where your data is, so you're not worrying about cross-account, cross-cloud data egress fees that can add up very, very quickly. Implement least privilege as much as possible. Plan for RBAC. We all know that legal and finance wants very granular things. It will come. Plan for it. And then implementing security in depth. So again, keep these in mind, but embrace flexibility as your business grows. Next, I'll welcome up Alan. Excuse me.
All right, thank you, Dom. All right, my name is Alan. I'm a software engineer at Anyscale. So Dom sort of talked about how we can build AI safely on Anyscale. So in this section, we're going to take a look at another challenge, which is AI is expensive, and what are the tools that Anyscale offer to help you manage that cost. If I can figure out this. There we go. So we think about this in two ways: proactive controls and reactive controls. Proactive controls simply are tools that help you set limits and monitor activities before the spending occurs. Reactive controls are tools that help you understand what happened after the spending occurs. So let's take a deeper look at proactive control tools. So we all want to build things, we all want to move fast, but we all also concerned about cost. But AI is complicated, meaning there are not only technical challenges, but there are also many different ways that you can overspend. Okay, so one feature that we have to help you manage that cost is budgets. This simply allows you to set usage limits on clouds, projects, and user level. So as Dom alluded to earlier, because you can set up your organization in ways that fits how you manage your teams and how you manage your workloads, it's also important for you to have the flexibility to set usage limits on clouds if like all your projects are organized by clouds or projects or even users. But this doesn't address all the problems. AI comes in many different shapes, so you can have like very large job that's very expensive, or you can have like 1,000 jobs that's cheaper, but add up to a significant amount. That's sort of why we built resource quotas. This is a feature that allows you to set limits on the number of instances and GPU types per cloud project and user as well. So let's take a closer look at this UI as an example. Say you're building a project that uses a lot of A100s, and then you want to organize all the people working on the project inside a specific cloud, inside a specific project. And then you want to limit the number of A100s for every researcher to be 12. Well, first of all, if you have 12 A100s per researchers, congratulations, good for you. But more importantly, this is the level of flexibility that resource quota allow you to set to not only remove the concern of cost and overspending, but give you the flexibility to move fast and innovate the way that you want. So reactive control tools are great, and then they help you stay under budget. Still, at the end of a big project, you may rack up a big bill, and people may start asking questions about the details. And at this point, you can like hand wave saying, we made this amazing model, it does all these things, and then we have to use a lot of expensive GPUs, but it doesn't really address the accountability and transparency that people are expecting. So that's why we build detailed usage logs. So this is a file that you can download on your organization to give you down to the instant second level on exactly how your compute was used. Which user, which cloud, which region, whether it's service, jobs, and all that. And we also have resource tagging. This is a feature that allows you to tag the resources that are launched from the Anyscale platform. And these two combine to give you a holistic view on how your usage happened across Anyscale and cloud provider of your own. So takeaways for this section: Anyscale offers cost management tools that not only remove the concern and give you a peace of mind for cost and overspending, but give you also the flexibility to move fast and build things. And we also offer tools that help you maintain transparency and ensure compliance. Aside from what's already mentioned, we also have audit logs, which help you monitor API activities that happen across the Anyscale platform. Cool. So we talked about tools that can help us manage costs, but how do we improve? How do we find room to like drive down the cost, not that we can manage it? So in this section, we're going to talk a little bit about the observability tooling that we have to help with that. So as a platform and as a problem in general, you can really launch a lot of clusters. Each cluster can be thousands of nodes across different cloud providers, different regions. And really a challenge that we all face is what's going on and how do you identify and optimize for inefficiencies. So Anyscale, every cloud has come with an isolated Grafana instance. This is where all the metrics from data planes get shipped and persisted. This is a very common pain point for open source Ray users. Having persisted logs not only help you debug tricky issues such as auto memory, disk usage, and also you can monitor network bandwidth. But with this centralized persisted log metrics for Grafana, you can also build dashboards like this to help you understand how you're using the compute in general inside the cloud. So for example, here we have a dashboard that shows SPA utilization. So this is one area that you can really drill down on, maybe using Anyscale's SPA fallback on demand feature to really understand how much SPA instances you are using and then who is using them and when. So that was logs, and that was metrics. So here, let's talk a little bit more about logs. As you've probably seen in the keynote demo, we have this advanced log querying feature that's right in the browser, which is also persisted logs from all the data plane instances. This gives you really the details to search logs across all the components inside your Ray clusters. And it's really critical in debugging problems such as auto memory. So here I want to touch on one of the more important lessons we learned as we build Anyscale as a platform, which is it's really critical to not only build tools that provide out-of-the-box values, but it's also critical to think about the users that will be using this and ways that they can integrate with these tools. So for observability, which is Vector is the component that's critical for that mission. Vector, if you don't know, is an open source software that make it easy for you to build observability pipelines. So it lets you collect and ship metrics to wherever you want, and blocks as well. So Anyscale, we use Vector to provide differentiate value for observability, but also allow you to configure to ship logs wherever you want. Like they support dozens of sinks and destinations that will, such as Datadog and Prometheus, that will make it easy for you to have a holistic view on your observability infrastructure. So just to recap, Anyscale provide observability enhancement that help you understand and optimize your system, but we also make it easy for you to integrate with your own existing system. Okay, now I'm going to hand it over back to Dom to talk a little bit about automation and how that plays into your AI platform journey.
All right, thank you, Alan. When it comes down to scale, automation is key. Because the reality is the vast majority of compute will not be triggered by a human inside of a console. And we kind of learned this the hard way. We learned that a console-first mentality doesn't fit with most common workloads, and it creates some complex interfaces, especially when you have a platform that has as many knobs to turn as Anyscale. If you try to build a UI component for every single one, you're going to have a bad day. So our approach is to actually build an API first, and then build parity inside of our CLI and SDK. So as you're thinking about your applications, you have a long-term vision on how this actually fits into your production systems. But a big part of that is actually integration with CI/CD. Unless you have a strong API, this is simply not going to work. But Ray adds a new flavor of complexity. Ray itself is complex. There are many ways to deploy, especially when you're talking about jobs and services. So what we've done is we've taken it a step further by building more comprehensive APIs that make it easier to deploy both jobs and services. By building out features like job queues, allowing for reliable queuing of Ray jobs on a cluster, or like services, which has a whole set of capabilities. Some of the ones that we like to highlight: zero downtime upgrades, so we can actually spin up a brand new cluster and with one endpoint do a canary rollout to that cluster. Another feature that we've seen very popular over the last year or so is something we call surge deployments. Especially if you are deploying using A100s, you may not have an additional capacity to deploy a brand new cluster. How do you surge the capacity by 20% and still ensure a safe rollout? These are some capabilities that we're able to expose via our APIs. And then ultimately integrating with a pipeline also involves credentials. We're not going to open up our endpoints for everyone. So we need a way to trigger these actions that aren't necessarily coupled to individual users. This is where service accounts become very critical. So wrapping up here, security sits at every level. You need to think about your platform in a way that allows for a flexible model that can fit with your current setup, but also as your organization scales. AI can be costly, so investing in both proactive and reactive controls can help you ensure that you don't hit a cost wall. Observability across multiple workloads is critical, not only for debugging, but also transparency and visibility. And then finally, planning for scale by investing in an API-first design will ensure that you can scale your platform with your developers, your business, and your new workloads. Thank you. And as a reminder, Anyscale is hiring, so reach out to us if interested. Do we have time for questions? Well, we have time for questions, if anyone.
You have mentioned Amazon and GCP. What's the support on Azure? And you have said AKS. So can you actually deploy on Azure Kubernetes if you're using Kubernetes?
Yes, we can. So this was one of our big launches this morning. So we can support Azure through a Kubernetes-based deployment. So everything that you see in terms of being able to launch jobs, services, workspaces, the observability components, that's all available on Azure via AKS.
Got it. So that means if we run AKS, you can kind of like hook into that and manage the clusters, run it, and all of that.
Correct.
Okay. Thank you.
There will be a talk tomorrow at 3:15 where we'll dive deeper into that architecture. Okay. No further questions. Thank you very much for. Go ahead.
Is there? So we actually run Ray, but then we run Cube Ray, and we run just open source Ray. Mm-hmm. And I was interested in the control plane aspect of Anyscale. And just to get started, can you manage open source Ray clusters through the Anyscale control plane, or your only option is to spin up the turbocharged Ray clusters?
Does Anyscale have the ability to launch and manage open source Ray clusters? Yes, it does. But the Ray Turbo variant is really just a set of features on top of open source. So would be interested in learning a little bit more about your use case and see if there's an easy path to upgrade there. Otherwise, yeah, certainly open to discussion there.
Got it. Thank you.
If there are no further questions, we'll be hanging out for a little bit longer if anyone wants to come up. But thank you for attending. Hope you have a good rest of your Ray Summit.